Curiosity has been analyzing this area between sols 4838 and 4844. A sol, for our listeners, is a Martian solar day, which is just about 39 minutes longer than an Earth day.
Okay, I need you to explain this boxwork terrain to me, because when I hear the word boxwork, I immediately picture a massive abandoned warehouse full of rotting cardboard boxes.
Right, which is definitely not what's on Mars.
Right. We are talking about Martian rocks. How does rock form a box?
Let's use a better metaphor to visualize the mechanics of how this forms. Imagine you take a wooden crate and you pour wet, highly durable concrete into all the tiny cracks and seams between the wooden planks.
Okay, I'm picturing it.
You let that concrete dry until it is rock hard. Then you set the wooden crate on fire.
Oh, wow. Okay.
The wood completely burns away, but the concrete that seeped into the cracks remains, leaving behind a rigid, intersecting web-like grid that perfectly outlines where the wood used to be.
Oh, wow. Okay, that makes perfect sense. So what was the wood and what was the concrete on ancient Mars?
Brilliant question. We're talking about a period billions of years ago when Mars had abundant flowing groundwater. The wood in our metaphor was the existing, softer, sedimentary bedrock of Mars.
Okay.
That bedrock had fractures and faults. The groundwater, which was rich with dissolved minerals, seeped into those cracks.
Oh, I see where this is going.
Over long periods of time, those minerals precipitated out of the water, essentially crystallizing, and filled the cracks with a much harder substance, usually mineral veins. That was our concrete.
Right.
Millions of years later, the Martian climate changed. The water disappeared, and relentless wind erosion scoured the planet. The softer bedrock eroded away completely, leaving only those hardened mineral veins standing upright in this bizarre, intersecting, box-like pattern.
That is wild.
It is. Curiosity has been carefully examining specific structures within this ancient web named Salar-de-Maricunga and El Misti.
So it's essentially the fossilized ghost of ancient Martian groundwater.
Yeah.
The negative space of a lost ocean. That's hauntingly beautiful.
It really is.
And Curiosity is doing this analysis using laser spectrometry, right? Like literally zapping the rocks to see what they are made of.
Precisely. It uses an instrument called ChemCam. It fires a high-powered laser at a pinpoint area of the rock. The laser is so intense that it instantly vaporizes a tiny fraction of the rock, turning it into a glowing plasma that reaches thousands of degrees.
Wait, it creates literal plasma on the surface of Mars.
It does. And as that plasma cools, the atoms within it emit light at very specific wavelengths.
Oh, interesting.
The rover's built-in spectrometers then read that emitted light, because every chemical element produces a unique optical signature. A specific barcode of light scientists back on Earth can look at that data and determine the exact chemical composition of the rock.